All right, systems of inequalities. So here we're going to graph both of these inequalities, and then we're going to see where do they overlap. So starting off with number one, I'll make the top one orange and the bottom one green, just so that it's easier to see. The top one, we graph it as if it was, we pretend that there's a little equal sign there, right? And we graph the line. So we're going to say, well, the intercept is at -1, and the slope is 1/3, so that means up 1 and over 3. And I could go down 1 and left 3. And then we have the question of, is it going to be a solid line or a dotted line? Well, remember that if it's like with an equal sign under there, it's a solid. But if it is just a plain old inequality with no equals, it is a dotted or a dashed or whatever word you want to use there. So here I'm going to have to use a dashed line, just like that. Now what's going to be different here is that I have to graph another one. So before I shade the whole thing, I'm just going to put little arrows telling me what direction I should shade. So I'm going to plug in the point 0, 0. 0, 0 is right there. So I'm going to say, well, 0 is greater than 1/3 times 0 minus 1. So 0 is greater than -1. Well, that's true. So I am going to shade this direction. I'm going to shade towards my 0. Now I'm not going to actually shade now. I'm going to graph my other line, and I'm going to see what direction that line goes in, and I'm going to shade where they would overlap. So the green one, my intercept is at 2. My slope is 4/3, so up 4, 1, 2, 3. Well, I can't go up 4, but I could go down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. So this line, another dashed line, is going to be like this. Now I'm going to need to plug in 0, 0 for it also. So here's my 0, 0. And I'll say, well, 0 is greater than -4/3 x. Oh, not x. I'm plugging in 0. 0 plus 2. And then I'm going to have, well, 0 is greater than 0 plus 2. Is 0 greater than 2? And the answer is no. 0 is not bigger than 2. So I'm going to shade away from the 0. So the spot where they both hit is going to be like right there. So there we are. So the orange one, and don't write this down, the orange one shades all of this. The green one shades only this. And we pick out the point where they overlap. All right, let's do another one and see if it makes more sense. Number 2, again, I'm going to label, or not label, I'm going to color code my 2 lines. And so the first one, I have an intercept of 2, a slope of 5/2. So I want to go up 5, but I'm not going to be able to go up 5, so I'll go down 5. 1, 2, 3, 4, 5, and over 2. So there's going to be that. And I'm going to have a dotted line. So there's my orange line. I'm going to plug in 0, 0 just to see. So 0 is less than 5/2 times 0 plus 2. So 0 is less than 2. That's a true statement. So I'm going to shade towards 0, 0, 0, 0 being right there. Right? So I draw my little arrows there to say, well, I'm going to be shading towards that direction. Now, me having colored pens, I could just shade, but I recognize that whenever you have pencil, it makes it a lot more difficult to tell, well, have I shaded here? Have I not shaded there? What color is this shading? So that's why I use the arrows. So again, I recognize that I don't really need the arrows right now because I have my colors, but whenever you're doing it in pencil, I think it's a lot easier if you use the arrows. So onto the green one, I'll have an intercept at -2. My slope is 1/2, so I'm going to go up 1 and over 2, or I could go down 1 and left 2. It's going to be a dotted line. Like that. Now for this one, I'm going to plug in 0, 0 again. And I'll say, well, 0 is less than 1/2 times 0 minus 2. So 0 is less than -2. And the question is that a real statement? And no, it's not. So I'm going to shade away from the origin, away from 0, 0. So I draw my little arrows on here. And I look, where would they overlap? Well, right over here, I can see, well, they overlap right there. So they would overlap all of this area here. Right? And again, don't draw this, but this would be if we had shaded it in both of them. There would be my orange, and then here would be my green. And we'd see, well, they overlap down there over on the yellow. All right, so there we are. Number 3. So my top one will be orange. It has an intercept of 2 and a slope of 1/3, so up 1 and over 3, or down 1 and left 3. It's a dotted line, so just like that. The second one, I'll make it green, has an intercept at -2, and again, a slope of 1/3, so just like that, and it's a dashed line. Oh, I forgot to plug in for orange. Let's plug in the origin for orange. We'll plug in 0, 0, so I'll say, well, 0 is greater than 1/3 times 0 plus 2. And the question is, well, is that a true statement? So I've got 0 is greater than 2. That's not true, so orange is going to shade like this. It's going to shade away from the origin. The green one, let's plug in 0, 0 there. So I'm going to say, well, 0 is less than 1/3 times 0 minus 2. So 0 is less than -2. Is that a true statement? And the answer for there is also no. So we're going to shade this direction. So if we were doing this by hand, what you would do is you wouldn't shade anything. But let me double check and see what Kudo lists this as. I'm wondering if they have a fancy word for it. We're on number 3, right? Nope, Kudo will just graph the 2 lines and no shading, right? Because there's no spot that they overlap. All right, number 4. All right, the first one, we'll make it orange. It has an intercept at -3 and a slope of 6. So I'm going to go up 6 and over 1. This is the first one that has a little line underneath the inequality, so we're going to have a solid line. And whenever I plug in 0, 0, I'm going to say, well, 0 is less than or equal to 6 times 0 minus 3. So 0 is less than -3. And that's not a true statement, so we're going to shade away from the origin. All right, for the second one, I'll make it green. It'll have an intercept at 2 and a slope of 1. So I'm going to go up 1 and over 1. It's going to be a dotted line because it doesn't have a line underneath the inequality. Like that. And I'll plug in 0, 0. So I'll say, well, 0 is greater than 0 plus 2. So 0 is greater than 2. Is that a true statement? No. So I'm going to shade, here's the origin. I'm going to shade away from it. So now we have to decide, where do we shade? Where do we actually shade together? And if we look up in this region, the orange line covers and the green line touches too. So it's going to be just this little sliver there. All right, there's number 4. Moving on, number 5. The first one has an intercept at -1 and a slope of -1/3, so I'm going to go down 1 and over 3, or I could go up 1 and left 3. And it's going to be a dotted line because there's no line under the inequality. The second one, I'll have an intercept at -3, a slope of 1/3, so I'll go up 1 and over 3, or down 1 and left 3. It's going to be a solid line. Oh, and I forgot again to plug in the orange line. We'll plug it in now. So here's the origin. The origin is 0, 0. I think I've been using those words interchangeably, but they mean the same thing. So I'm going to plug in 0, 0 for the orange one. I'll say, well, 0 is greater than negative 1/3 times 0 minus 1. So 0 is greater than negative 1. Well, that's a true statement. So the orange one is shading up. The green one now, I'm also going to plug in 0, 0. So 0 is less than 1/3 times 0 minus 3. So 0 is less than negative 3. Now, is that a true statement? No. So we're going to shade away from 0. So again, we should see that this little sliver down here is going to be the solution. And what we're doing here, I don't know if I've talked about it yet, we're finding the spots or the points that would satisfy both equations, right? We don't want it to just satisfy the orange equation or just satisfy the green. We want it to satisfy both. So we have to graph them together and we have to find where they overlap, where they both would be shaded. All right, moving on to number 6. I'll have my top one be orange. It'll have an intercept at 2, a slope of negative 1/2, so down 1 and over 2, or up 1 and left 2. It's going to have a dotted line because there's no line under the inequality. I'll plug in the point 0, 0. So I'm going to have, well, 0 is greater than negative 1/2 x. Oh, not x, I'm plugging in 0. 0 plus 2. So 0 is greater than 2. And that's a false statement, so I'm going to shade away from 0. All right, now for the green one. I have an intercept at negative 3 and a slope of negative 3. So I'm going to go, well, I want to go down 3 and left, or excuse me, down 3 and right 1, but I can't do that. So I'll go up 3 and left 1. It's going to also be a dotted line. I'll plug in 0, 0, and I'll say, well, 0 is greater than negative 3 times 0 minus 3. So 0 is greater than negative 3. Now that's a true statement. 0 is bigger than negative 3. So I'm going to shade towards the 0. And we can see that the spot where they overlap is going to be this chunk up here. And just because I'm going to shade them like I would, like you would normally, the orange one would shade this region up there. The green one would shade that over there. And we can see that they do overlap right there, where the yellow is. I'm going to erase that so we can see what we're doing. All right, there's number 6. Moving on to number 7. X is greater than negative 3. That is a vertical line at the point negative 3, and it's going to be a solid line. Now for x is greater than negative 3, I'm going to say, well, I could plug in 0, 0. That would give me 0 is greater than negative 3, which is a true statement. So I'm going to shade towards 0. For the orange one, I need to graph that. The intercept is at 1. The slope is 4/3, so I'm going to go up 4 and over 3. Or I could go down 4 and left 3. It's going to also have a solid line. I'll plug in 0, 0, and I say, well, 0 is greater than 4/3 times 0 plus 1. So 0 is greater than or equal to 1. And that is not a true statement, right? 0 is not bigger than 1, so I'm going to shade away from the origin. This one's really easy to see that it overlaps in this region here. All right, there's number 7. And last one, number 8. The top one here has an intercept at negative 1 and a slope of 1, so that's really nice to graph, up 1 over 1. it's going to be a solid line. And for the green one, it'll have an intercept at -3, and it has a slope of -1. So I'm just going to, I'll draw my points. It's going to have a dotted line, right? Oh, I forgot to plug in points. The orange one will plug in 0, 0, the spot where the axes cross. The axes, yeah, axes. So 0 is greater than or equal to 0 minus 1. So 0 is bigger than -1. Well, that's a true statement. So I'm going to shade towards 0. The green one, 0 is less than -0 minus 3. So 0 is less than -3. Well, that's not a true statement. 0 is not smaller than -3. So I'm going to shade away from the 0. This one too, I think, is easy to see that we're going to shade that region there. All right, there we are.